Welcome to Reimagining Technology with the Engineering Science program. Engineering science has the power to reimagine technology by blending scientific understanding with innovative engineering design to create groundbreaking solutions that shape the future. I am Erik Birgersson and the director of the Engineering Science program in NUS, ESP in short. Let's start by asking the question, what is engineering science? You've probably heard of mechanical, chemical or electrical engineering before, but perhaps not of the Engineering Science program. In Singapore, ESP is relatively young. It was launched in April 2006 as a flagship educational initiative at NUS. We are fully accredited by the Engineering Accreditation Board. In short, the mission of ESP is to train engineering scientists who can solve multidisciplinary problems, develop innovative designs, integrate systems, and work at the interface of disciplines. But what does this look like in practice? For example, consider the challenge of improving urban comfort in Singapore's hot and humid climate. A traditional approach might involve mechanical engineers designing better air conditioning systems or civil engineers optimizing building layouts for ventilation. An ESP-trained engineering scientist, however, would take a multidisciplinary approach, combining fluid mechanics, thermodynamics, material science, and AI-driven simulations to develop an innovative, large-scale air delivery system. Such a system could, for example, create microclimates at bus stops or public spaces, lowering the apparent temperature while minimizing energy consumption. This ability to integrate knowledge across disciplines and develop novel solutions is what sets ESP graduates apart. Our student cohort consists of around 50 students per year, allowing for a more personalized education with greater interaction between students and professors, both in the classroom and labs, as well as outside of class. In the top left figure, you can see students and professors collaborating on a project in our Faraday lab. The top right and bottom figures showcase a strong sense of community within ESP, with students and professors mingling at social events such as our Chinese New Year celebration and Mid-Autumn barbecue at West Coast Park. These events also bring together alumni and industry professionals, providing valuable networking opportunities. Building connections with alumni and industry early on can open up doors to internships, research collaborations, and career opportunities, giving you a strong foundation for your future career. Now, how do we achieve our mission of training multidisciplinary engineering scientists? ESP has a diverse team of academic staff from mechanical engineering, electrical engineering, physics, and material science and engineering, along with adjunct faculty from local agencies and industry. Our faculty members come from around the world, bringing a wealth of expertise from different disciplines. This diversity is a key strength. With faculty members actively engaged in research, industry collaborations, and real-world problem solving, students gain exposure to a wide range of perspectives, methodologies, and applications. Whether it's advancements in AI, next-generation energy solutions, or biomedical innovations, our staff's varied backgrounds ensure that students are not only learning fundamental principles, but also seeing how they are applied across different fields. Additionally, our student-to-academic staff ratio of approximately 10:1 allows for a more personalized learning experience, fostering close mentorship, deeper discussions, and opportunities for hands-on research alongside faculty. In ESP, we offer hands-on small class experimental courses and projects together with interdisciplinary core courses in both science and engineering. The theory from the classroom is brought to life in our 4 labs. In the Faraday lab, top left, you can explore and build your own sensors, design and test an earthquake-resistant tower to learn about forces, and explore heat and mass transfer in your own scaled-down industrial dryer. In the design studio, bottom left, you can work on design projects such as efficient air conditioning systems and sensors for energy savings in green buildings. In the multidisciplinary lab, top right, you can fabricate nanostructures with a bottom-up approach by growing small units into larger nanostructures. In the nanofabrication lab, bottom right, you can build your own lab on a chip and fabricate nanostructures with a top-down approach by breaking down bulk materials into nano-sized structures. To give you a clear picture of our ESP curriculum, here's an overview of some key multidisciplinary courses you'll be taking. The blue-collared courses on the left focus on experiential learning. These hands-on courses involve engineering design projects, industrial attachments, and final year research project where you apply theory to real-world challenges. The green-collared courses in the second column provide a strong foundation in physics, covering quantum mechanics, solid-state physics, and electromagnetics. The purple-collared courses in the third column span mechanical and electrical engineering, including feedback and control, signals, thermodynamics, and the principles of continua. In the Principles of Continua course, for example, you'll explore fluid mechanics, solid mechanics, and heat transfer through their shared fundamental principles, culminating in a project such as designing a large-scale air delivery system to create a microclimate in Singapore, or developing a novel face mask with an improved thermal envelope. The orange-collared courses on the right focus on mathematics and numerical methods, delving into advanced mathematics, machine learning, and AI in engineering science. These courses are designed to integrate theory and application, ensuring you not only grasp fundamental principles, but also see how they translate into real-world solutions. In addition to the core courses, ESP offers 4 specializations that allow you to go deeper into your subject of interest. These are Nanoscience and Technology, where you work at small scales, for example, fabricating nanodevices. Computational Engineering Science, where you work with AI, robotics, and simulations from atoms to continua. Energy Science and Technology, where you can work on sustainability and renewable energy. And finally, Engineering Science and Medicine, where you can work at the interface of medicine and engineering science, for example, for medical imaging. All specializations have a good mix of courses from mechanical engineering, electrical engineering, and physics. They are all multidisciplinary. In addition, popular second majors and minors for ESP students include physics, data analytics, and innovation and design. These areas of study complement the ESP program by providing additional skills and knowledge that enhance students' ability to tackle complex problems, innovate, and adapt to a wide range of industries and challenges. Everything you learn in our courses, combined with our hands-on projects, will equip you with both hard and soft skills. In the figure, you can see the wide range of skills you will develop, ranging from engineering knowledge, problem analysis, design of solutions, investigation, use of modern tools, to communication, project management, and lifelong learning. To ensure our students acquire these skills, we conduct an annual graduate exit survey, as shown here for the cohort graduating in 2024. I'd like to draw your attention to the green bars in the figure, which indicate that graduating students agree or strongly agree that they have gained these skills. This feedback is critical as it helps us continuously refine and enhance our curriculum to align with industry needs and emerging technologies. By maintaining this adaptive approach, we ensure that our graduates are not only well prepared for their first jobs, but also equipped with the mindset and skills to thrive in an evolving engineering landscape. Moreover, if you're passionate about physics and want to delve deeper into physics, you could choose our double degree program, which would allow you to graduate with 2 honors degrees, one from ESP in the College of Design and Engineering, and 1 degree from physics in the College of Humanities and Sciences. Since the ESP major already features courses from physics, you will be able to double count up to 16 units, making it easier for you to complete both honors degrees. ESP is also part of an international consortium with other engineering science programs around the world, which allows for more opportunities for student enhancement programs. For example, Cornell University USA, KTH Sweden, University College London UK, and University of Toronto, Canada. Many of our ESP students go on a student exchange around the world, as shown in the examples here. For instance, some have studied at ETH Zurich, the University of Auckland, and Osaka University, among others. These experiences offer valuable exposure to different academic and cultural perspectives, helping students broaden their horizons and build global networks. In addition, all ESP students complete an internship as part of their studies, gaining hands-on working experience. Upon graduation, they find jobs in a wide range of industries and companies. Here you can see a sampling of companies where our students have gone on to work, such as process engineer at Micron, graduate engineer at ABB, research engineer at A-Star, and wind power engineer at Siemens. With a solid multidisciplinary foundation gained through our program, you will be well prepared for a diverse range of career opportunities throughout your lifetime. Some ESP graduates have also gone for further graduate studies. Here is another sampling of universities our students have gone to for graduate studies, such as a master or a PhD. For example, Yale, Harvard University, MIT, and Caltech. Now, if we look at NUS, highlighted in orange to the right, you can see ESP graduates who have done PhDs in biomedical engineering, chemical and biomolecular engineering, electrical engineering, mechanical engineering, material science and engineering, and physics in NUS. This is where you truly see how multidisciplinary ESP is and how good we are with our fundamentals. The training we give you allows you to go for PhD studies in a range of disciplines. You might wonder how employable our ESP graduates are. The figure shows the mean gross monthly starting salaries for programs in the College of Design and Engineering and the College of Sciences and Humanities at NUS from 2020 to 2023. ESP graduates, highlighted with a dashed box, have consistently commanded high starting salaries, even achieving the highest salaries in 2020 among the programs shown here. Employment rates have also been strong, demonstrating that our students can secure jobs upon graduation. Let me summarize why I strongly believe that ESP is a good place to be. You will get strong scientific fundamentals in cutting-edge engineering applications. You will gain hands-on experimental confidence in our labs, working on design projects and assignments. You will be able to work across disciplines with the strong multidisciplinary nature of our program. And finally, we're small, around 50 students, allowing for a more personal style of education with educators from different disciplines. Having said that, do not worry that it would be more difficult to apply to us, given the small number of students. We are flexible with our intake numbers. Please scan the first QR code to view more information on ESP and the second to find out more about other CDE programs. Thank you.